In this session, we're going to talk about some types of numbers. So we've got square numbers first of all. These are when you have 1 squared, 2 squared, 3 squared, 4 squared, and so on. When I square something, it means to times it by itself. So 1 squared would be 1 times 1, which is 1. 2 squared would be 2 times 2, which is 4. So these answers, 1 and 4, are square numbers. Carrying on, it would be 9, 16, 25, and so on. I then have what's known as cube numbers. These are very similar, but when I cube something, I times it by itself and then itself again. So 1 cubed would be 1 times 1 times 1, which is 1. 2 cubed would be 2 times 2 times 2, which is 8. So my cube numbers are 1, 8, 27, and so on. You've then got cube roots and square roots. Now these are the opposite of cubing and squaring something. The symbol looks a bit like the bus stop method from division. It's a small symbol like this. If it's the square root, it will just be like that on its own. If it's the cube root, it will have a small 3 next to it. So we can find the square root or the cube root of any number. It just means, what number did I square in the first place to get this answer? So if I wanted to find the square root of 4, I need to think, what number did I multiply by itself to get the answer of 4? 2, because 2 squared is 4. If I want to do the square root of 49, I've got to think, what did I multiply by itself to get 49? 7. 7 squared is 49. So the square root of 49 would be 7. Cube root is a little bit harder, because I've got to think, what number did I multiply by itself and then itself again? So these ones, you won't be expected to know very big numbers. The highest one you would be expected to know is 125. The cube root of 125 would be 5, because 5 times 5 is 25, times 5 again is 125. So the cube root of 125 is 5. If I wanted to work out the cube root of 27, I can do it trial and error. I can just say, well, what's 2 cubed? 2 times 2 is 4, times 2 is 8. So it's not 2. 3 times 3 is 9, times 3 is 27. So I found it. The cube root of 27 is 3. Now we need to introduce a few more definitions. Firstly, a multiple. A multiple of a number just means the times tables. So the multiples of 4 would be the 4 times tables. 4, 8, 12, 16, and so on. They're the multiples. We then have factors. Factors are the numbers that go into something. So what can I multiply to get that number? So the factors of 20, for example, would be 1 and 20, 2 and 10, 4 and 5, because I can multiply those pairs of numbers to get 20 as an answer. The final definition is a prime number. Prime numbers are special because they only have 2 factors, and that's 1 and itself. For this reason, some mathematicians argue whether 1 is a prime number or not. We've decided it's not, because its only factors are 1. So that doesn't have 2 factors, okay, because 1 is itself. So we can't count it. So our first prime number would be 2, because its only factors are 1 and 2. The next prime number would be 3. Its only factors are 1 and 3. Then 5, 1 and 5, and so on. After 2, there will be no more even prime numbers, because every even number can be divided by 2, so it's therefore got more than 2 factors. So now we've looked at prime numbers and factors, we're going to combine the two and write something as a product of its prime factors. So that means we can take any number and write it as a product of its prime factors. Product means multiply. So all we're going to do is have some numbers that multiply together to give us our answer. But what's special about these numbers is that they're all going to be prime and they're all going to be factors of the number we started with. And we do this by using a factor tree. So for example, let's start with 18. We'll have 18 at the top of our page. I'm going to split that into some factors. So I can split 18 into 2 and 9. Once I've then split it, I need to look at my two numbers, 2 and 9. Are they prime? 2 is, so I'm going to circle it because it's a prime number. means I can't go any further, so I stop there. 9, however, is not a prime number, so I'm going to keep going, and I'm going to split that again. 9 I can split into 3 and 3, so 3 and 3. I then look again. Are they prime numbers? Yes, 3 is a prime number, so I circle them both, and that means I've finished. Once your numbers are all circled, you can't go any further, so you're done. Now these circled numbers are your prime factors. They're prime numbers and they're factors of 18. So to write them now as a product, I'm just going to write 2 times 3 times 3. If you were to put that in your calculator, the answer would be 18. There's only one way I can write it a little bit tidier. I can use index form, because 3 times 3 is the same as saying 3 squared. So I could write 2 times 3 squared.